Assalamualaikum and salam sejahtera. Okay, previously we already discussed on how to solve if we have the differential equation in separable and homogeneous form. Okay, so for each type of equation, they have their own step on how to solve the equation. Okay, in this video, I would like to explain about how, uh, if we have the linear differential equation, how to solve the equation. But first, okay, we check this is a slide for the linear equation. So, but first, we need to check the linearity, okay, the definition for the linearity from our chapter 1. So the linearity, the definition for the linear ordinary differential equation of order n. Okay, if you have the ODE of n in n order, then the differential equation is linear if we have the equation in this form. Okay, well, okay, let's say for this equation we have where is my pen? Okay, if we have y, okay, as the function of x, okay, y as the function of x, so which means in this equation y is the dependent variable. So for the linear ordinary differential equation, okay, for all dependent variables term, whether the function of the derivative, okay, must be in power of 1 less than 1, and must be the power must be integer number only, okay, less than 1 and 1 and less, like that lah. Okay, and must be integer number. Okay, for example, if we have, let's say we have, okay, dny over dx as the power of 1 over 3. Okay, this equation is not linear. This is not linear equation. Okay, because of the power of this power. Or if we have the function of y, okay, in a function of y in exponent y. So this is the equation also not the nonlinear equation. Why? Because of the exponent function, okay, of y. Okay, only for the dependent variable, in this case y. Okay, this this form is the linear form. Okay, linear form. I mean about if we have the dependent variable for the power of 1 less than 1 and less. Okay, we go back to our linear equation. Okay, the differential equation in form, we have the same form as the previous definition, only we cut at the dy over dx only. So the differential equation in form ax dy over dx plus bxy equals cx is called first order linear equation, where ax, bx and cx are a function of x or constant. Okay, so the same function, the same function, good. Okay, as the previous definition, we have y as the function of x. So which means y as the dependent variable. So for the dependent variable, if the equation is linear, so y is only can be power of 1 and less. Okay, that is the definition for the linear equation for the first order. How to solve linear equation? first, of course lah, we need to determine, okay, whether the differential equation is linear or not. Okay, just same as the separable and also homogeneous. Okay, I already explained in the homogeneous equation. The one equation, okay, one differential equation, one ordinary differential equation can be separable, homogeneous, or linear, or can be also can be separable and linear, let's say, and also can be homogeneous and linear. So for one differential equation, can be classed as several types of equation. That means we can solve by using several solutions, several equation, several type. Okay, so how to choose the best solution? So if the question does not if the question does not mention whether you need to use the specific method, specific equation, you can choose which one that you more comfortable with the step and so on. Okay, but my suggestion, okay, the easiest, of course, the separable. Okay, because we just need to separate x and y, then integrate. Okay, the second easier method is homogeneous. Okay, because for the linear equation, okay, we need to use the integrating factor. I will explain about the integrating factor later. Okay, but if the question asks you, okay, to use the specific method, you need to follow the question. Okay, but in real situation, in real life, if we have the problem, then we don't know the what type of the differential equation. Then we just check whether the equation is separable or homogeneous or linear, and the other one is exact, and maybe there are several types of differential equation out there. So then we just use the step, okay, the next step to solve. Okay, we go back to the linear equation. Okay, after we determine whether the differential equation is linear or not, okay, so for the second step, if we need to rewrite the equation in form dy over dx plus bx equal y, where p and q now are a function of x, a constant. Okay, what does it mean by rewrite? Okay, we look at at our definition in the previous slide. Okay, the differential equation is defined as ax dy over dx plus bx y equals cx. Okay, we define the linear first order ODE as this form. Okay. What is the difference between the equation that we must be rewrite? Okay, can be rewritten as dy over dx. What is the difference is the coefficient for dy over dx. Coefficient for the term dy over dx. Okay, in this you look at my cursor. Okay, in this equation, okay, we want the differential equation, the coefficient for dy over dx as 1. Okay, but from the definition of linear, so we have the equation as ax. Okay. So here, if we have this the solution, the differential equation, we just rewrite by divide Okay, divide by divided all terms with the coefficient. Okay, if our coefficient is ax, so divide by each term as ax. Okay. So divide each term with the ax. So divide over dx, the coefficient now is 1. Okay, so plus the coefficient for the y is bx over ax. Okay, plus equal the coefficient of not the coefficient, but the cx becomes cx over ax. Okay, bx over a and cx over ax now is p and p and q. Okay, that one is for the second step. Rewrite. So step 3, we need to find the integrating factor. Okay, rho. Okay, the integrating factor rho is defined as exponent. Integration, power of exponent is integration of p dx. Okay. What is p? P is the coefficient for y after we rewrite the equation. Okay. Then finally, this is the final step. Before, if we don't have the condition. Okay, the final step is we write rho y equal integration of rho q dx. Okay, same as apa tu nama, homogeneous, same as homogeneous. Okay, this formula we not provide this formula, so you have to memorize it. Okay, actually it's not difficult, just to need to memorize the step. Okay, the differential the step. What is rho? Then rho y equal rho q. Okay, because p has been used in power of for the integrating factor. So rho y equal rho q dx. Okay, then what we need to do is for the left hand side, we just let it be as rho y. Okay, but for the right hand side, this is the integration of rho q dx. So integrate for the integrate right hand side. So we have the solution is mx plus a. Okay. What is okay? How from the differential equation? Okay, from the differential equation, the linear. How could this transform to the rho y equal rho x? How to transfer it to this formula? So we look at the next slide. My next slide. So from step 3 until step 4. Okay. What we can do is we need to introduce okay, what we do is we introduce the integrating factor. Okay, so for the integrating factor rho, we multiply with the linear equation, the differential equation. Okay, then for the sum derivation, okay, differentiate implicit differentiation. So finally, this integrating factor, okay, bring the differential equation to this formula. Okay, so if you want to know how from the differential equation combined with the integrated factor becomes this formula, so you can check my next slide. Okay, so this is from the step 3 until step 4. Okay, so this is just the additional knowledge. If you don't know, if you think that this is not important for you, so just let it be. Okay, just memorize that we have the integrated factor, so we can then we can write, okay, the differential equation, because we want to we want to solve this differential equation. So rho y equal integration of rho x dx. Okay, and just the same step as the previous type of differential equation. If we have the initial condition, we can substitute into the solution to obtain the value of a. Okay, so we will learn the solution of linear equations in example. Okay, so I will explain about the example. Let's say we have example one. So example 1a. Okay, so we can check. Okay, first we can check whether, because the linear equation is quite easy, because um we just can determine whether the differential equation linear or not, using by just by looking at the form. Okay, sorry. Okay, just by looking at the form of the differential equation. Okay, for example, in this equation, okay, so it is obvious. Okay, if we not rearrange y to the left hand side, it's okay. Okay, so this is actually obvious that the differential equation is linear, because we have our dy over dx power of 1 and y also power of 1. Okay, so this is linear. That's all. Okay. So when we have the we have a linear differential equation. Okay, so we want to use this integrative factor and so on. So first we need to rewrite, okay, the linear differential equation in form. We need the a coefficient for dy over dx as 1, so dy over dx plus py equal q. Okay, so the coefficient is 1. So for this example, we have coefficient as x plus 1, so never mind. Okay, we just divide by x plus 1 for each term. Okay, divide by x plus 1, so we have dy over dx. Okay, okay, we bring the y to the left hand side, so minus. Okay, y is 1, so because we divide each term by x plus 1, so for y we have 1 over x plus 1 times y equal x over, still x still need to be divided by x plus 1. Okay, because we need to divide each term. Okay, each term, so each x plus 1, for example, so y x plus 1, x also x plus 1. Okay, be careful. Okay, after this, so we have okay, exactly the same um, form as this one, dy over dx. So we need to identify the p and q. Okay, so in this problem, our p is here. Okay, so you be careful, because we have the sign negative here. So for the differential equation, okay, the general form for this, the differential equation, we have the sign plus sign, plus sign, but here we have the negative sign. So this is actually the plus negative, plus negative. Okay, so you need to be careful here. Okay, if you already understand this is the negative, then this is the ni p must be negative in negative term, then that's okay. If you don't understand, so you need to rewrite. Okay, rewrite exactly as this one. So if divide by dx is the coefficient 1, so coefficient 1. If the next term is plus, so next term must be plus. Okay, so plus because of this is negative, so must be plus negative lah. Okay, so the next one is q. Okay, so then our p is negative 1 over x plus 1. Be careful. Once again, I always say be careful. Okay, because from my experience, so students always forget about this negative term. Okay, so q is x over x plus 1. Okay, so next we need to find for the integrating factor rho. So rho is negative exponent p dx. So exponent integration of p, our p is negative 1 over x plus 1 dx. Okay, exponent integration of 1 over x plus 1 is negative ln x plus 1 x plus 1. Okay, so you don't need to put the plus c, okay, because this that one will be multiplied with the constant also, so just like it as this equation. Okay, we want to eliminate the exponent. We can eliminate exponent and ln, but first, okay, we need to bring the negative sign to the power of function inside the ln. What does it mean? Okay, so you need to revise back okay, so the make some revision about the ln. Okay, the ln part. Okay, so the ln, if we have a ln b, okay, where a ln b, so this is actually ln b power of a. Okay, I think this basic for the ln exponent, you learn it in your school day, right? Okay, so we have negative here, so negative. Okay, exponent negative bring to the s the power, so ln x plus 1 power of negative 1. Okay, so we can eliminate. Okay, we can normalize exponent and ln, so this becomes x plus 1 power of negative 1, or we can write as 1 over x plus 1. This, that is the rule. Okay, we want the rule. So I rewrite this to make it easier to look. So rho is 1 over x plus 1. Okay, this is the integrating factor. After we obtain the integrating factor, okay, so we can move to the next step where we have rho y equal integration of rho q dx. So rho y, rho 1 over x plus 1 times y. Just let y dy. Okay, so equal rho is 1 over x plus 1 times q. What is q? So our q is x over x plus 1. Okay, okay, x over x plus 1. Is that correct? I think so. Okay, so after this, okay, we dx. Okay, after this we need to integrate for the right hand side only. So for the right hand side we have x equal x plus 1 power of 2 dx. Okay, this is quite easy integration. Okay, this just the substitution. Let me check the answer. I'm afraid that I give you the wrong solution. Yeah. Okay. Correct. Okay. This is actually quite easier, but um, still you need to think how to solve this integration. So for this integration, actually we just use the substitution u equal x plus 1. Okay, so du over dx equal 1. Okay, so we have dx equal du. Okay, if we substitute into the integration, so we still have x. Okay, this substitute with u squared dx is du. What can we do with x? Okay, so we want to integrate u in terms of u. We cannot have x in the integration, and we cannot assume x as a constant. Okay, what we can do is we go back to our substitution u. So from u here we have x equal u minus 1. Okay, so substitute x here as u minus, divide by u squared du. Okay, then separate the fraction. So u, because we have the minus sign at the numerator. Okay, at the numerator, so there should be no problem to divide this to separate this fraction. Okay, so separate for the left, u over u squared is 1 over u minus 1 over u squared d. Okay, so for the 1 over u, this is actually ln u. So for the next, I don't want to write it once again. So u is, this is actually u negative 2. Okay, so u negative 2, so negative 2. So if we integrate, so negative 2 plus 1 is negative 1 times negative, divide by negative 1. This one is positive u negative 1 u okay, plus a. Okay, then substitute back u, so we have ln x plus 1. Okay, plus what u negative 1 is 1 over x plus 1 plus a. Okay, you can leave it as this function, but you also can bring the x plus 1 to the right hand side. So from y can continue as this. So we have y equal 1 plus x, bring to the right hand side, so we have 1 plus x times all terms. 1 plus x or x plus 1, so x plus 1 x plus 1 plus a. So final answer is x plus 1 Okay, so ln x plus 1. Or you can bring x plus 1 as the power of x plus 1. Right, so plus, okay, x plus 1 divided by x plus 1 is 1. Plus, okay, for a, don't change a to the another constant. Okay, so you cannot change a to the another constant. Let's just write a times x plus 1. Okay, you cannot change a to the another constant. Remember that. Okay, that's all. That's the final answer. Right. Okay. Uh, okay, for the example one, okay, we try. Once again, we try to check whether the example one is also another type. Okay, so right here, okay, we have x plus 1 dy over dx equal y plus x. Is this dy over dx is separable? So we try to separate. So dy over dx. This is not the separable. Y plus x, because we cannot separate x and y, not separable. So if this not separable, how about the homogeneous? So for the homogeneous, let's say this is the fxy, so we substitute f lambda x. That's a simple checking. Lambda x lambda y, so substitute y as lambda y plus x as lambda x divided by lambda x plus 1. Okay. Okay, this is also not the homogeneous. Why? Okay, for the numerator we can factor out lambda. So of course we can factor out lambda because both terms have lambda. Okay, y is y plus y. Okay, this is x. Okay, for the denominator, so if we factor out lambda, okay, lambda x is becomes lambda x, but for the 1 it will become 1 over lambda. So if we eliminate lambda, we still have another lambda here, and this is not equal fxy. For example 1, okay, it's only the linear equation. I don't know whether the equation is exact or not. Okay, when we move to the exact equation, you can check by yourself whether the equation is exact or not. So, this is example B. So, example B, obviously, once again, example B is nonlinear. Why? Because of the term y squared. I hope you can see this. Because of the term y squared. This is nonlinear equation. Nonlinear equation. Okay, linear lah. So we cannot use the solution of linear differential equation. We must check another type of differential equation. You can check by yourself. I think this is not separable. Not separable. But this is also non-homogeneous. Right, non-homogeneous. So you can check. And perhaps this is the exact. Okay. So you can check by yourself. Now, for the example C, obviously. Okay, example C. How about the example C? Okay, so for example C, we check for the function of y. So dy over dx is power of 1. So okay, and y also power of 1. So this is okay. This is the linear equation. The linear equation is, I think linear equation is the easiest equation that can be identified. Okay, whether they linear or not, because of the form. Okay, because of the linear form. Okay, but it's quite tedious actually to solve. Because what? Because of the integrating factor rho. But actually it depends on the problem. So let's say, okay, this is the, okay, we apa ni, we show that this is the linear equation. Okay, we have shown that this is the linear equation. So we need to rewrite, okay, into the form dy over dx plus px, px plus by equal q. Okay, so for the coefficient for dy over dx, already 1. However, we need to bring the y to the left hand side. So rewrite dy over dx, bring y to the left hand side, y and also the function, the coefficient. So negative 6xy equal to x. Okay. So if we compare, okay, the general form, the form with our apa question. So for the second term p, we have here is positive, but this is negative. So you can change is positive, negative 6x. Okay, but if you already know this one is negative, so of course lah positive negative, but of course the p is negative. So apa, it's okay, that's okay. Okay, if you cannot see, you cannot understand, so you need to change the negative sign to the positive negative. So what we want to have here is p. So p if negative 6x and q is 2x. Okay. Then we need to find the integrating factor rho equal exponent p dx. Okay, just substitute exponent p is negative 6x dx. So this is exponent negative 6 is the integration x is x squared over 2. Also negative 3x. Okay, x squared, negative 3x squared. Because the integration is x squared over 2, so bahagi-bahagilah. Divide this, simplify, negative 3x, exponent negative 3x over 2. So after we obtain the integrating factor, so you write rho y equal integration of rho x dx. Okay, so for the rho y is exponent negative 3x squared times y. Okay, so for the integration we have rho exponent negative 3x squared times apa rho x. What is rho x? Rho q. It's not rho, this is not rho x. This is rho q. Sorry. So rho is rho. So this is rho exponent negative 3x squared q is 2x. Okay, dx. Okay. So for the left hand side, let it be exponent and y. But for the right hand side, we need to think how to integrate this term. Okay. Okay, if you look at, we have the exponent and x. Okay, perhaps you can think that this is the by part. Okay, we cannot do the by part term. Why? Because we cannot integrate exponent 3x squared. Okay, but for this equation, actually it's the simple equation. Once again, this is just the substitution. So what we can substitute is this term, because if we substitute u as negative, substitute the power of exponent, so negative 3x squared. You can just take u as x squared, never mind. Okay, so you also can take all terms. Okay, negative 3x squared. So we have du over dx equal negative 6x. Okay, negative 6x. Then it's up to you how to do the substitution. But for me, I just substitute dx, the whole dx as du over negative 6x. Okay. Substitute into the equation, the integration. So exponent u times 2x dx is du over negative 6x. So we can eliminate x, and we also can simplify the number, okay, the constant. So this is what, negative 1 over 3, yeah? 1 over negative 3, or negative 1 over 3 exponent eu du. So this is just a simple integration exponent eu plus a. So substitute back u, negative 1 over 3. So u is negative 3x squared plus a. Right? You can just leave the answer as this answer. Okay. Or you can bring as y, bring the exponent. So I think I need to make it clearer. So I need to put, let's say I leave here. So I have 1 over x plus 1 y, right? I need to put in this line. So for this question, so I also the left hand side, we have our left side exponent negative 1 over 3 x squared y. To make it clearer, okay. Never mind if you just leave your solution like this, like this. Right, this solution. Look at my cursor. So for, okay, if we want to simplify for y, so y, we can divide each term by exponent negative. Negative 1 over 3 exponent negative 3x squared divided by exponent negative 3x squared. Sorry, negative 3. Why 1? So negative 3. Okay, plus a also divided by exponent negative 3x squared. Okay, so you can eliminate this. Okay, so y is negative 1 over 3. Negative 1 over 3 plus. You can leave a is a divided by ni, or you can bring the exponent to the beside a. Okay, but we need to change the sign for the exponent. Okay. Once again, okay, for the term a, we cannot change to the new constant. We cannot change to the new constant. When we can change to the new constant, okay, if we have a times exponent b. Okay, exponent b is constant, so we can change to c. Okay, or if we have a times ln a and ln b, ln b is also constant. Constant times constant is the new constant. Okay, why? This is not the constant, this is the function of x. So we cannot change a divided by any function of x as the new constant. Just leave a times and the function just that in that form. Okay, so for the next example number 2. So example number 2, just the same. I actually repeat the same step of solution, just as the previous. Okay, what is it? What's different is only the integration part. So we have here the dx over dt plus 2x equal t squared. So this one you need to be careful because of the variable. Okay, now our function is x equal ft, which means our x is the dependent variable. Okay, x is the dependent variable, so we need to check for x. So x power of 1, x power of 1. So this is linear. Okay, linear. So when this is a linear equation, okay, we can find for the integrating. Not. So we need to rewrite. But for this example, we don't need to rewrite in the term, in the what in the general form. Okay, because the differential equation is in the form that we want. So we have dx over dt power of 1, but the coefficient is 1. So then we have the x here. Okay, so just just the in the correct form. Okay, so we just need to identify. Okay, p, what is p? P is now the coefficient of x, so p is 2. So q, what is q? Q is our t squared. Okay, remember that this is the different variable. So if you cannot understand how x, how t, how, so you can change this to y equal fx, which means function of the variable x you can change to y, the variable t you can change to x. Okay, if you cannot understand this, if you can understand this, just use this variable. Okay, if we change, if we change, okay, so y, so the differential equation becomes, okay, change y, which means x equal y, t equal x. So x equal y, so we have dy, t equal x, dx plus x equal y equal t equal x squared. So we can use we can refer the previous example. So I want to use the variable from the question. So p is 2, q is t squared. So our integrating factor is exponent. Okay, now our x, okay, is what no. So from here our x is t. So exponent p dt. Okay, change dx. Previous integrating factor of dx to dt. So rho equal integration of exponent p dx. So integration of p is 2 dt. Okay, so integration of 2t. Okay. This is the integrating factor. Then we write rho y equal integration of rho q dt. So rho exponent to t, y just not y, because y now is our x. So rho x to t x, okay, equal integration of rho is exponent to t, q is t squared dt. Okay, once again, we need to check, okay, which technique can we use to solve the integration. This integration, okay. So for this integration, uh, we cannot use substitution. Okay, we cannot use substitution because if we substitute this as 2t, we still have t in the equation. You can try. Okay, so for this equation, we can use by part tabula. Okay, so I already explained about the tabula by part from my previous example, so you can check. I don't remember which examples, but you can check. Okay, so by part, so we have these two parts. Okay, so we have two parts, exponent and polynomial. So we need to choose which part that we can differentiate. We have u, we have gb. Okay, so linear. Which part is u? So depends on the which one comes first from the lineage. So ln, inverse, algebraic. Okay, trigo and exponent. Trigo and exponent can be exchange, both dispose, but whether the exponent first or trigo first. Okay, which one? These two can be exchanged. Why? Because it give the same result. Okay, so for this case, we have exponent and polynomial. Polynomial is under the algebraic. So polynomial algebraic. So cos and trigo at the bottom. So of course we choose u as t squared. So the dv as exponent to t. Okay. So u, we need to differentiate. dv we need to integrate. So until when we need to differentiate? Until we get integration of 0. Okay. So t squared integrate to t, integrate to integrate once again is 0. Okay, then stop. So for the exponent, just follow the integration of t squared. So for the exponent to t, integrate exponent to t divided by 2. Okay, integrate once again exponent to t divided by 4. Integrate once again exponent to t divided by 8. Okay, so we have the arrow there. So for the arrow there, we alternate. Positive, start from positive, positive, negative, positive, negative. Okay, actually for the last term, we still have the integration of 0, but since there's 0, this just can be constant. Okay, in other words, we don't need to consider this this term. Okay, just like it. So positive. So for the what is the result? So we have positive t squared times exponent to t divided by 2. Okay, negative, so negative 2t exponent 2t divided by 4. Okay, plus exponent not exponent, plus 2 only 2 exponent 2t, okay, divided by 8 plus a constant, okay, from the by part. So actually from the by part we already have the answer. Okay, simplify. So simplify 2, so 2 so so we have this as the final answer. Or okay, we can divide each terms with exponent t, so we have the final answer also as x. So divide by exponent t, So t squared exponent, not exponent t, exponent 2t, yeah, divided by 2 minus t over 2 plus 2 berapa? 1 over 4 plus a exponent negative. Okay, so you can check this. How from this it comes the less defined answer. Okay, but if you don't want to make, if you're afraid that you can make any and you will make any mistake, so just leave your answer as this. Okay. And for example number 3, we have the initial value problem. So we have the initial condition. So first we need to check. So we have xy prime. Okay, I will change xy prime as dy over dx plus 2y equal x squared minus x plus 1. Okay, so this is we check. Okay, we check if our function is y and the dependent variable is y. So for y, okay, for the power of y is all 1. So this is also 1. So then we need to rewrite. So we want to rewrite. So first we need to make the coefficient for dy over dx as 1. So we need to divide by x. So dy over dx plus, okay, so we have 2 here, so 2 over x, y, okay, equal, divide each terms by x, so x squared divided by x is x, minus x divided by x is x, and not x divided by x is 1, okay, divided by x each terms, okay, plus 1 over x, then, okay, we have the form dy over dx plus py equal q, okay. So we want p. What is p? P is 2 over x. P is the coefficient of y. What is q? Q is x minus 1 plus 1 over x. Okay. After we have p, so we can find for integrating factor, exponent, integration of 2 over x. Lompat terus. So p dx. This is exponent, p is 2 over x dx. Apa saya buat ni? This is exponent 2 over x dx. Okay. Exponent 2 ln x. Okay. Once again, we can normalize or can eliminate exponent and ln. Okay, we can normalize actually exponent and ln, but we need to change, we need to bring the 2 into the power of x. Okay, exponent, rewrite this as x power of 2. Remember that if we have any coefficient before, any constant or any function before ln x, we need to bring as the power if we want to eliminate exponent and ln. Okay, remember that. So exponent and ln now becomes x. Okay, so we have rho is 4. I write back rho as x squared. Yeah, the solution is here. Okay. Okay, rho as x squared. So divide by the integrated factor. So rho y equal integration of rho x dx. So rho y is x squared y equal rho x is x squared x is also x. No, sorry, not rho x, rho q. I always forget q. So x squared. So q tadi x minus 1 plus 1 over x. So this is only the simple, just a very simple integration dx. The polynomial integration. It's your rezeki lah. Okay, if the integration is simple, that is your rezeki. We call it your rezeki as a student lah, dapat soalan senang macam tu So multiply x squared with the terms in the bracket. So we have x power of 3 minus x squared plus x squared divided by x is x. Okay, for the right hand side, integrate, we have x power of 4 over 4 minus x power of 3 over 3 plus x power of 2 over 2 dx plus a. Okay, you can leave it here, or you can find for y. So y, okay, bring x squared to the right hand side, so we need to divide the right hand side with x squared. So we have x squared over 4. Do it one by one if you cannot see how this become this. Okay, so x cubed divided by x squared is x over 3 plus 1 over 2 plus, once again, this is a over x squared. Leave it. Okay, don't change to the new constant. Several times I warn you that you cannot change a times any function, okay, with the new constant. Okay. Actually I forget. Okay, this is not the final. Where is my pen? Okay, this is not the final answer. Sorry, because we still have the condition. Okay, I forgot about the condition. So y1 equal 1 over 2. So we need to substitute the condition. So we have y1 equal 1 over 2. Y1 equal 1 over 2. That is means when x equal 1, y equal 1 over 2. Okay, we substitute x and y into the solution, the general solution. This is general solution because we have constant. Okay, so we need to find the particular solution specific for the initial, the condition given. So y 1 over 2, okay, equal x is 1, so 1 squared is 1 over 4, 1 over 3 plus 1 over 2 plus a over 1 is a. So what is a? So we can use calculator, just use the calculator. So 1 over 2, okay, minus 1 over 4 plus 1 over 3. Be careful about the sign, positive and negative. 1 over 2 minus 1 over 4 plus 1 over 3 minus 1 over 2. It's 1 over 12. So our a is 1 over 12. Substitute back a into the solution. So y is x squared over 4 minus x over 3 plus 1 over 2 plus a is 1 over 12. 1 over 12. So 1 over 12 x squared. Okay. That is the final answer. Okay, we finish about the linear equation. So thank you.